A delta-style circuit breaker is a type of circuit breaker commonly used in commercial and industrial applications. It is designed to interrupt the flow of current in a three-phase electrical system. The circuit breaker consists of 3 poles, each of which is connected to one of the 3 phases of the system. When a fault occurs on one of the phases, the corresponding pole of the circuit breaker will trip, interrupting the flow of current through that phase and isolating the faulty circuit. The other 2 poles will remain closed, allowing the other 2 phases to continue operating. To understand the function and application of a delta-style circuit breaker, it is important to first understand 3-phase electrical systems. 3-phase power is a method of electrical power transmission that uses 3 alternating currents, each separated by 120 electrical degrees. This means that the voltage in each phase reaches its peak at a different time, resulting in a smoother and more constant power delivery compared to single-phase power. 3-phase systems are commonly used in industrial and commercial settings because they can deliver more power for a given wire size and are more efficient for running large motors and equipment. Delta and Y are the 2 common configurations for 3-phase systems. In a delta configuration, the 3 phases are connected in a closed loop, resembling the Greek letter delta. There is no neutral point in a pure delta system, but a grounded delta system can have one phase grounded, which creates a neutral point. In a Y configuration, the 3 phases are connected to a common neutral point, forming a Y shape. Y systems are often used when both 3-phase and single-phase power are required. Now let's focus on the delta-style circuit breaker, delving deeper into its functionality and application. Firstly, understanding its construction is critical. It contains 3 poles, one for each phase of the 3-phase system it protects. This 3-pole configuration is the defining characteristic of a delta-style breaker. Each pole is essentially a separate circuit breaker that can operate independently. Secondly is the fault interruption process. When a fault, such as a short circuit or overload, occurs on one phase of the 3-phase system, only the pole corresponding to that faulted phase trips. The tripping mechanism is designed to quickly interrupt the current flow in the affected phase, preventing damage to equipment and reducing the risk of electrical hazards. Thirdly, the isolation of the faulty circuit is how the breaker prevents the fault from propagating to the other phases. By tripping only the affected pole, the delta-style breaker isolates the problem, allowing the remaining phases to continue operating without interruption. This is particularly important in industrial settings where downtime can be costly. Then the continued operation of unaffected phases is an important advantage. The delta-style breaker allows the unaffected phases of the 3-phase system to continue operating even when one phase experiences a fault. This is because the other 2 poles of the breaker remain closed, maintaining the electrical connection to those phases. This ensures that critical equipment and processes powered by the other phases can continue running, minimizing disruption. The applications of delta-style circuit breakers are numerous. They are commonly used in industrial facilities to protect motors, transformers, and other critical equipment. They are also used in commercial buildings to protect lighting, HVAC, and other electrical systems. Delta-style circuit breakers are available in a wide range of sizes and ratings to accommodate different applications. The appropriate size and rating of the breaker will depend on the specific electrical load being protected and the characteristics of the 3-phase system. They are typically installed in electrical panels or enclosures along with other circuit breakers and protective devices. They can be operated manually, using a handle or switch, or remotely, using a control system. Regular inspection and testing of delta-style circuit breakers are essential to ensure their proper operation. This includes visually inspecting the breaker for any signs of damage or wear, as well as testing its tripping function to verify that it responds correctly to faults. In summary, the delta-style circuit breaker is a specialized type of circuit breaker designed for use in 3-phase electrical systems. Its ability to isolate faults and allow the continued operation of unaffected phases makes it a valuable component in commercial and industrial settings. By understanding its construction, function, and applications, one can appreciate the importance of this protective device in ensuring the safe and reliable operation of electrical systems. It is always important to consult with a qualified electrician or electrical engineer when selecting, installing, or maintaining Delta-style circuit breakers. They can provide expert guidance and ensure that the breaker is properly matched to the application and that all applicable safety codes and standards are followed. The current rating of a circuit breaker is the maximum amount of continuous current that it can carry without tripping under specified conditions. It is typically marked on the breaker's housing in amps. The interrupting rating of a circuit breaker is the maximum amount of fault current that it can safely interrupt. It is also typically marked on the breaker's housing in amps or kiloamps. When selecting a circuit breaker, it is essential to choose one with a current rating and interrupting rating that are appropriate for the application. The current rating should be high enough to handle the normal load current, while the interrupting rating should be high enough to handle the maximum fault current that could occur at the installation location. Failing to select a circuit breaker with an adequate interrupting rating can result in the breaker failing to clear a fault, which can lead to equipment damage, fire, or even personal injury. National Electrical Code, or NEC, provides guidelines for selecting and installing circuit breakers. Section 240.6 provides standard ampere ratings for fuses and inverse time circuit breakers. Section 240.83 covers marking requirements for circuit breakers, including the ampere rating and interrupting rating. Section 408.36, mentioned earlier, provides requirements for overcurrent protection in panel boards. It specifically addresses the use of delta breakers and similar devices. Delta breakers are a specific design of circuit breaker. NEC 408.36d addresses the use of single-pole circuit breakers as branch circuit overcurrent devices in panel boards. Specifically, it prohibits the use of single-pole circuit breakers connected to two-wire circuits derived from a three-phase system having a grounded neutral conductor, with the voltage to ground on such circuits exceeds 120 volts. This rule is intended to prevent situations where a single-pole breaker could leave a high voltage to ground an ungrounded conductor, creating a safety hazard. If the voltage to ground exceeds 120 volts, a two-pole or three-pole circuit breaker is required to provide adequate overcurrent protection. The NEC is a comprehensive set of standards, and understanding its requirements is crucial for ensuring electrical safety. Consider a scenario where a three-phase, 480-volt system has a grounded neutral. The voltage from each phase to ground would be approximately 277 volts. According to NEC 408.36d, using a single-pole breaker on a 277-volt circuit derived from this system would be prohibited. A two-pole or three-pole breaker would be required instead. Now let's talk about other types of circuit breakers. In addition to delta-style circuit breakers, there are other types commonly used in electrical systems. Standard thermal magnetic circuit breakers are the most common type. They use a thermal element to trip on overloads and a magnetic element to trip on short circuits. Electronic trip circuit breakers use electronic sensors to detect overloads and short circuits. They offer more precise and adjustable tripping characteristics compared to thermal magnetic breakers. Molded case circuit breakers are typically used for higher current applications. They have a robust construction and can withstand higher fault currents. Insulated case circuit breakers are similar to molded case breakers but offer higher insulation levels and are used in high voltage applications. Choosing the right type of circuit breaker depends on the specific application and the characteristics of the electrical system. Factors to consider include the voltage, current, interrupting rating, and desired tripping characteristics. Regular maintenance and testing of circuit breakers are essential to ensure their proper operation and safety. This includes visual inspections, insulation resistance testing, and trip time testing. Any damaged or malfunctioning circuit breaker should be replaced immediately. In conclusion, understanding delta-style circuit breakers, their function in three-phase systems, and the relevant NEC requirements is essential for anyone working with electrical systems in commercial and industrial settings. Proper selection, installation, and maintenance of circuit breakers are crucial for ensuring electrical safety and preventing equipment damage. Always consult with qualified professionals and adhere to applicable codes and standards when working with electrical systems. Safety is paramount, and taking the necessary precautions can help prevent accidents and ensure the reliable operation of electrical equipment. Remember that electrical work can be dangerous. Always de-energize circuits before working on them and follow proper safety procedures. If you are not qualified to perform electrical work, consult with a licensed electrician. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with qualified professionals and adhere to applicable codes and standards when working with electrical systems. Staying informed and following safety guidelines is crucial for maintaining a safe and reliable electrical system.